Now let's talk about series circuits. Series circuits are very straightforward, and I think you're going to like them. Pretty much, in a series circuit, you have some sort of battery, and then you have any number of resistors in, you got it, series. So here's my potential. Let's call this R1, R2, and R3. Now, you know there is some current coming out of the battery, and that's going to supply the same current to all of the resistors. So you know that the current going through the first resistor has to equal the current going through the second resistor, etc. And that has to equal I. Now, you know the equivalent resistance is the sum of all of the resistors. Plus, we can go on forever. Now, what else do we know? We know the voltage across any one resistor is going to be the current going through that resistor times that resistance. So you need to find I. You can find the voltage across each resistor. Okay. The final thing you know is that the sum of the voltage drops is going to equal your battery resistance. So when you do one of these problems, there's quite a number of things I can actually ask you to do. I can ask you to draw it. I can ask you to find the current, and you're going to know all the currents are the same. You can find the equivalent resistance. Now, suppose I ask you to find the current. You've got the battery voltage is equal to I, R equivalent. So I guess the fourth thing I can ask you to do is find the current. And so that's going to be my battery voltage divided by R equivalent. And you have to start here. You cannot start here. The next thing I can ask you to do is find the voltage drop across each resistor. And you can always check with the sixth thing, this is just a check, to make sure all of your voltages add up. So let's try one. Suppose I have a 9-volt battery. All right, so I'm going to come over here and I'm going to draw a 9-volt battery. And it's connected to 4 light bulbs. Now, it does not matter the order you put the light bulbs in. They can be around corners just like I'm drawing them. That's okay. Whoa, sorry. Here we go. Here's V. Here's R1, R2. I'm kind of tired here, so I apologize for the sloppiness of my handwriting. So this is my battery voltage. Write out your givens. This is 9 volts. R1 is 2 ohms. R2 is 4 ohms. R3 is 5 ohms. And R4 is 7 ohms. Now, the first thing I ask for is the equivalent resistance. This is the first thing you want to do, is to find the equivalent resistance. And this is how you would, oh, sorry, my pen is messing up. This is how you'd find the equivalent resistance. Let me clean this bottom of this little circuit up here. After you've gripped this pen for a couple of hours, it does get to be hard, let me tell you. All right, so the equivalent resistance is R1 plus R2 plus R3 plus R4. So this is 2 plus 4 plus 5 plus 7, or 18 ohms. So the battery sees basically just one great big resistor of 18 ohms, not all of these individual resistors. Find the current. So the current now is just V is I, R equivalent. So the current is the battery voltage divided by R equivalent. The battery voltage is 9 volts divided by the equivalent resistance of 18 ohms, or 0.50 amps. Now, what if you have several light bulbs connected in series across a 115 volt voltage source. So this is V. What's the equivalent resistance if the current is 1.5 amps? We're going to work backwards. All right, so V battery is 115 volts. And the current, the total current, is 1.7 amps. And we want to find R equivalent. V equals IR. I know you're going to get tired of this. And that's R equivalent. So R equivalent is the voltage divided by the current. So this is 115 volts divided by 1.7 amps. And when you do this, you get 67.647 ohms. Now, if each bulb has a resistance of 1.5 ohms, so the resistance of each bulb is 1.5 ohms. How many light bulbs are there? Okay, well, let's see if we can kind of draw a picture here. Okay, here's my battery. And let's just put all the resistors on one side. R1, R2, R3, dot, dot, dot. We're going to leave a little break here because we do not know how many there are. Okay, so this is V, R1, R2, R3, R4, down to Rn. So we're looking for Rn. Or we're looking for N, is what we're looking for. If each bulb has a resistance of 1.5, how many light bulbs are there? Well, I know R equivalent is the sum of R sub I. It's just R1 plus R2 plus R3 plus dot 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 plus Rn. Or it is N times the resistance of one bulb. So N is going to be the equivalent resistance divided by the resistance of one bulb. The equivalent resistance we got is 67.647, and the resistance of one bulb is 1.5. So we get this as 45.0 what? 0.09 bulbs. This is close enough. We'll just set the rest of it off to round off.